Hey guys, it's Mike, and in this video I'm going to show you how to create this super simple transition effect. And if you'll notice, this transition effect is a little unique in the sense that you notice the image it's using is only 256 by 256. So how is it able to create and size accordingly the area on the left, right, top, and bottom? Well, we're actually able to do that with some simple geometry math, and I'm going to show you how to do this in Unity, but the cool part is that what I show you in this video will apply theoretically to any game engine, etc. So let's take a look at a quick example that I drew up in Photoshop. Okay, so we have our center mask image here, which is only 256 by 256, but it's also rendered at a specific size and a specific position. So that's a variable we need to know, along with our screen width and screen height. Now, pictured here is some pseudocode, basically just to assign x, y, width, and height of a given generic rectangle. And I added the outlines for clarity here. So you can see that if our keyhole image is here, rendered at a specific size and at a specific location, then we need a rectangle to be on the left side, a rectangle to be on the right side, and we also need a top and a bottom rectangle. Now, you can't just do this simply where you calculate left and bottom and use the same for top and right. Why? Because what if this effect were, say, starting here, or your character were over here and you wanted to start this effect? That's kind of why I brought the math into this, is because I wanted this effect to be able to take place anywhere and just calculate how much of the screen needs to be hidden based on the size and position of this effect. So it's super simple. And so now I'm going to show you how you can translate this pseudocode into Unity code. Okay, so I've just got this basic sprite here acting like a little 2D scene. Let's go to the scene view. So what I'm going to do is I'm going to create a UI canvas, and this is going to be our transition canvas. You can use a canvas that you already have, or whatever way you need to do this in your game engine will work too. Now I'm going to go ahead and I'm going to create a new image, and this image is going to be our mask image. And I'm just going to leave it pretty much as it is. You can see it's right here at the center of the screen at a certain width and height. But what's important is that for this to work properly, you're going to want to change not only the anchor, but the pivot point in Unity also. By default, Unity likes to put its center point, 0, 0, in the center of the screen, which is okay. And you could definitely make this effect work if your center point is at the center of the screen or in a different spot. But to keep my life simple, I wanted 0, 0 at the bottom left, and I wanted, let's say our screen size is 1280 by 720. I wanted 1280 to be the rightmost, and I wanted 720 to be the highest point. So in order to do that, you don't change it in the canvas, you change it actually on a per object basis. So for this rect transform, I need my anchors min and max to all be at 0, and I additionally need the pivot point to be at 0 also. Otherwise we'll get some positioning errors later on. So now you'll notice our mask image hasn't moved any, but our coordinates have changed. Before, our coordinates were 0, 0, and that put us at the center of the screen. If we put this image now at 0, 0, it'll be at the bottom left of the screen, and that's exactly what we want. And by not changing our pivot, actually, you can see our image ends up off screen. So at 0, 0, we need our full image to be in view and have its bottom left corner starting at the bottom left corner of the screen. Okay, now let's go ahead and create a mask transition script. We'll go ahead and open it in my editor of choice. Okay, so this is unrelated to this tutorial, and this is more so just a Unity tip. Make sure, even if it's just a testing script or whatever, just give it some kind of namespace, because if you don't give your script a namespace, when you go to flesh it out, finish it, and use it, and then you decide you want to move it into a specific folder, Unity will actually lose its link to the script if you don't have a namespace. So namespaces are important. I wish they were all created with one by default, but whatever. So I'm going to go ahead and I'm going to remove all of these methods, and we're just going to start from a blank slate. We need to store an array of 4 other UI images, and we're not going to create these in our Unity project view and then assign them. Instead, what we're going to do is we're going to create them when we're enabled. So our script is going to manage those 4 images, which for all intents and purposes are going to be our side racks. So how are we going to manage this? Well, with a simple array. Okay, so we're going to use Unity's image class here. And why? Because, well, use the image component. You can color it whatever you want. It can basically act as a basic rendering rectangle for all intents and purposes. It's the easiest way to draw a box in Unity at a certain position on the screen. And it also has access to the rect transform component that's associated with it, so it's kind of the perfect solution for this. And we're going to store an array of these, and we're going to have 4 of them total, and these are going to be our side recs. Right? Now, in order to make indexing these easier, I'm going to create a quick enum called sides. Sides. That's a bit annoying. And they're basically going to be left, right, top, bottom. And I want to make sure that I have initialized this array before I start using it, so I'm going to set this equal to a new image array. And I could hardcode the size 4, or I could take sides.bottom, which is 3, add 1 to it, but that's going to give me an error because I need to cast sides.bottom to an int. As you can see now, we're going to use the value from sides.bottom, which is our last component in our enum. We're simply adding 1 to it, and that way we've got 4 slots, and when we say image at index of sides.bottom, it'll get us the 3rd element in our array. When we do image at index of sides.left, it'll get us the 1st element, or the 0th element. And we're going to have our first external reference. This external reference is actually going to be to our mask image. And this mask image is our keyhole image, or it's the image that we're going to use to size all our other rectangles, which is why we need a reference to it. Next, we need to make sure that these rectangles are actually created in the scene before we do anything else. So I'm going to create an onEnable method here. And what I'm basically going to do is, for each of our images here, I'm going to create a new game object. Basically what I'm doing here is I'm creating a new game object with the name rectSide, plus I'm taking our index here, which is an integer, casting it back to our sides enum. And basically when Unity goes to resolve this string plus our sides enum, it's going to actually use the kind of text version of our enum. So we'll see rect side left, rect side right, etc., etc. And our second argument here is actually a variadic list of components we want attached to this game object. So by requesting that we have a type of image attached to it, we're actually requesting that we'll have that and a rect transform already on this game object when we create it. So we don't have to add these components. For good measure, I'm going to go ahead and make sure that our transform.parent is the same as our MaskImage transform parent, and this is because images will only render if they're in a canvas. If we have a mask image, it should be parented by a canvas, so we're just going to set our parent to the same as the MaskImage's parent. Next, we want to get a reference to our component here, so it's going to be new side rect.getComponentImage. And now that we have this reference, we not only have a reference to the image and all of its properties, like color, but we also have a reference to its rect transform just by typing .rect transform. And so just like our mask image, we're going to want to set the anchor min, anchor max, and pivot points. And it's very easy to do this through code, and as you know, they're all going to be 0, 0. And luckily, Unity actually has a little constant for that, so you don't have to create a new 0 vector every time you want to use that. But you just want to make sure that you're not only setting your anchors, but also your pivot points. If your pivot point is not also set to 0, 0, you'll get some strange issues where it's like almost there, but not quite. Finally, we want to make sure that our image is properly stored in our array. So sideRex at I is going to be equal to sideRectImage. Just like that. I'm going to create a small method to assist in calculating and setting the positions of these. Because remember, it's not just creating these components, it's also sizing and positioning them. So this is going to be simply a private void called setRectSizePositionBySide. our arguments are going to be a rect transform, side rect, and it's going to also take the side enumerator as its argument, so we know which side we're dealing with. Now, I was talking about variables we need to know, and luckily everything we need is easily accessible. For example, our screen width and screen height. It's a constant always available to us in Unity. And since we have a reference to our mask image, it's actually really easy to get its size and position. Position is managed by anchored position. And so I'm just going to real quick make a shorthand for this because that's a lot to type. Mask position. And I'm going to do the same for our mask size. Now, what's important to remember is that even though I only wrote mask size, again, this is our rendered size. This is not the 256 by 256 that this image is in Photoshop. It is the size that this image is rendering on the screen. And we need to know what side we're dealing with because that'll affect how we calculate our size and positions. So I'm just going to real quick make this case sides dot left break right. So I'm going to fill out left and right with you so you kind of understand how I'm going from our example PSD mockup here with our pseudo code to Unity code. We're going to set two variables on our side rect. We're going to set our anchored position and we're going to set our size delta. Now all we have to do is calculate these. So what's our anchored position going to be for our left side? Well, referencing the example image here, we can see that our x and y's are just 0. That's easy. So I'll go ahead and I'll set our anchored position equal to our vector2 0 constant. That's pretty easy. Our size delta is going to be a little more involved. We actually have to create a new vector2 for this, unfortunately, because there's a bug in the way Unity handles .set on vectors that aren't managed by C#. Oh well. But let's go ahead and look at our example one more time. So our width is going to be wherever our mask's X position is rendering. And our height is just going to match the screen height. That makes sense because you can see this rect takes up the whole side of the screen. And our width starts at 0 here and ends where our mask image starts. So new vector2 is going to be equal to mask position.x and screen.height. Okay, that was pretty easy. Let's do the right side, which is going to be a little bit more involved. To make my life easier and save some typing, I'm going to copy and paste these here. Y is going to be 0, but our x is actually going to be equal to our mask's x position starting here, plus the rendered width of it. You see how that works? We're taking our starting position and adding our rendered width, and that's how we're getting the x position of our right side. So it'll be new vector2 mask position.x plus mask size.x, and our y is going to be at 0. Our screen height will be the same, but we actually need to do a little more math to figure out what our width is going to be. All right, we're going to take our screen width, which is this whole full area, and we're going to subtract basically the value of our mask x plus mask width. So where our image ends here, we're going to take this number on the x and subtract it from our width. And that'll pretty much get us the difference between the right side of this image and what's left on the right side of the screen. So that's it for the right and the top, or for the right and the left. The top and the bottom are actually going to be pretty similar, so I'm just going to fill those out real quick without kind of guiding you along. Okay, so now that I've fleshed out the rest of this method, hopefully this all makes sense. Please leave any comments or questions you have regarding this in the description below, and I'll do my best to answer them in a timely manner. Now we want to actually make sure we're using this method. So after we create our object and we've assigned it to our array, let's go ahead and call setRect size and position by side. We're going to pass it in our side recs at i.rect transform, and our side is going to be our eye cast to our enum. It's that simple. So now, when we go back into Unity, let it compile. So before we just hit play, let's make sure that we've assigned our MaskImage reference, which conveniently is on the same game object as our masked transition script. Do a quick file save, and then when we play, we should see black squares surrounding our white square, pretty much perfectly. Alright, that is exactly what we wanted. Couldn't have asked for much better than that. Let's take a look at our scene view. In our scene view here, inspecting the canvas a little more, as you can see, we've got a left side rectangle, which is pretty much perfect, a right side rectangle, which again is pretty much perfect, and we've got a top and a bottom that are once again pretty much perfect. Now we're not quite at the point yet where this is going to dynamically update and resize as we move our mask image around. As you can see, nothing happens yet. So let's go ahead and add that code in real quick. So the easiest way for me to show you this updating in real time quickly is to add execute in edit mode up here. And so this will ensure that our onEnable is actually executed in edit mode. So we don't have to click play to get onEnable to run. And real quick, I'm going to say to only do this if siderex at I is equal to null. Actually, if siderex.I is not equal to null, we're going to continue. And then I'm going to come below our method here and just add a quick update. Now you could get a lot more complicated and obviously track the size and position of the mask image and only update our objects when that's updated, but just for this quick example, every frame I'm going to update all 4 of our objects. So for int I is equal to 0, I is less than side rex, dot length I plus plus. And then I'm going to call set rect size position by side, given our side rex at I, and our side, which of course is just our I cast back to our enum. And so it stops complaining. I'm going to say that it's our side rex at I dot rect transform. Boom. So now, once Unity recompiles every frame, it's going to update our rect size and positions for all 4 of our side recs. Okay, so as you can see in the game preview, without even hitting play, we've got our left, right, top, bottom masks here. Let's go to the scene view and let's move this around. Let's see what happens. Okay, as you can see, our rectangles are updating their sizes accordingly. We can resize this here like that. And even if they're bigger, you'll see they'll actually size negative to match. As we moved around, our left, right, top, and bottom move perfectly to match. Okay, so now all that's left is assigning our mask image to it, which it could be anything you want. In my case, it's this keyhole image. And now you can see in the game view, we've got our keyhole image masking the rest of the scene. And so this is on its own canvas. So this can literally be applied to a 2D or 3D scene. And as you can see, our scene view here is in separate space. It's in world space. And it's still pretty much perfectly masking everything as we've asked for. So I hope this helped you guys create a super simple mask transition effect, or even just some kind of masked effect. This is not only useful for transitions, this could also be useful for if you wanted to have a simple mask follow your character around. Say it's a super dark scene and you needed some kind of round light to follow them. That would be simple. You could change this image to a star and even have a rotating and animating star as you size and scale it down. Once again, let's show you what this final effect looks like. You could run this through a Unity animation controller. Personally, I like to do this all by code. That way I can ensure that my recs update at the same time as my mask image. And as you can see, it's just simple in and out. It's just simple scale and rescale with rectangle sizing to match. So if you guys enjoyed this video, please be sure to leave a like. Once again, if you have any questions, comments, or concerns, please leave them down in the description. I will do my best to answer them in a timely manner. And until next time, guys, peace out.